RADs, Remote Activated Doorway System. RADs offer many advantages over a traditional entry system. Increased security, increased convenience, assisting the handicapped, elderly, individuals with arthritis, and/or limited mobility.
RADs is a complex but simple system. It works off the microprocessor. RADs can work off of a 12-volt power system. It can be plugged into any household outlet.
Scenario 1. Imagine returning home at dark with your children, bags of groceries, an umbrella. It's raining, windy, and cold. You just want in the house quickly. One press of a button will allow hands-free entry using RADs. Once everyone enters, the door will automatically lock, providing increased family security, thus eliminating the chance of forgetting to lock the door. An individual with limited mobility, also having to manage goods, groceries, etc., can also utilize RADs. That can be Scenario 3. Once at home and security is no longer needed, the RADs system can be placed in manual mode. In manual mode, the door will function as a normal door, even though it is still microprocessor controlled.
When we first started to develop RADs, the idea came from whenever one of our students on this team went to go visit their grandma at a nursing home. And they noticed how much of a problem they had trying to get into the door of their house, just with mobility and the intricate motions from the keys trying to get the door to unlock. So that's how I came up with the idea to create RADs. For the construction process, first we got a door, which we got the door from an old motel. Door handle, hinges and everything included. And then we used wood from our wood shop to put together a frame and door jamb for the door. And then we started creating the plexiglass container, which would fit the solenoid, which acts as the locking mechanism. And then we started to do the programming for the circuit boards, continued to work on replacing hinges and making sure that the door would fit into our frame, which you can see in the background of this picture. Then we had to 3D print a container for the actual circuit board, which would house the microprocessors and all of the electronics for the thing itself. Next was designing the circuit board itself. We started just trying to figure out what exactly we wanted the door to do. So how it had to open, but it also had to open with the door handle and the transmitter. Then after we came up with the schematic, we created the actual circuit board layout that would go into the door itself. After we created that, we printed that out onto a piece of paper, and then we ironed it on to the copper-clad circuit board, dipped it in ferric chloride, and then ended up with a final product of the circuit board, which all we had to do was scrape off the black masking from the blue transfer paper. Here we have the solenoid. This acts as the locking mechanism. After we got everything put together and had all the pieces that we needed, we had to start assembling it and putting it together. We started by putting all the pieces onto the door, including the circuit board holder, the circuit board, the door handle, the solenoid, the reed relay and magnet for the reed relay. And with the door handle, we manufactured 2 pins that would fit together so that whenever you turn the door handle, it completes a closed circuit that informs the microprocessor that you have turned the door handle, allowing it to open. The programming wasn't too intricate, but just getting the correct loops to work together was slightly difficult. After we created the program, we programmed it onto the chip using an EPIC microprocessor programming software. And then after we got it all programmed, we tested it on our digital lab trainers.